go through this. I'm sure you'll have questions. Let me just go through some introductions. I'm Dave McCarthy, the ward counselor. Seen a lot of you folks at recent meetings. Just to go around the table, Dave Murphy, VP and engineer for Tiger Bond. Al Grazioso, DPW Commissioner. Paul Costello, a very, very valuable city engineer. And Ken Mavro George, who works for Tiger Bond also. Just so everybody knows, we are looking at this in segments. Tonight's meeting will concentrate on Peterson Road at the Willows and stop right before I get up, probably right about here, before I get into the Post Island area. We think, as we talked about this and as we pulled your input in, that we got some different areas where C Street, as you know, the houses are right up to the wall. Post Island, as you get to that bend, is a little bit set back with the marsh, and I think some folks here like that bathtub effect that we want to talk about a little bit, but that's going to be on October 9th. And then we go up the wall to Adams Shore, up to Shelton, and then up Chickatawbin. So tonight's just a C Street conversation up to, I read about Shoreside. Just to give, before I even get going here, a little history on today. Myself, Paul, Ken, and Dave were on the beach down there in front of a lot of your homes on C Street, eyeballing just exactly how close some of the folks have their decks up into the seawall, outfall pipes, just conversation in general. Also about the, not only the seawall, but also, and I don't know who lives, if everybody here is on the front, but we also have a conversation about the marsh in the back. So even though we come up with a solution, we think that's going to be pretty good for the wall. The concern also, which I don't want anybody to think we're neglecting, back in here behind PJ Foley's home is also going to be addressed. So right now it's just seawall and the possible improvement of drainage, but we'll end up back in that marsh later on, sometime in November. I've played phone tag and email tag with the Army Corps of Engineers, along with our city folks, the MWRA, and Tiger Bond. So there'll be a little powwow, because I know we all had concern after the water got in about how the water was going to get out. And we know we have this issue back here where we have to, at the boardwalk, rectify the culverts that are there so that we can release, if we need to, hopefully not in anytime soon, but to allow the water to go out. We know that's been closed up for quite some time.
Can you just modify the TRC to show the Rhoda Street, the twin culverts underneath this home right there?
Yeah. So C Street tonight, from the Willows, from the rock at the corner of Babcock and C, and then right all the way up to Post Island Road to talk about that entire strip. And then also, we won't get into deep discussion about this, but just for knowledge sake, we're coming back with that marsh. We're not just paying attention to the frontage. We got to pay attention to the rear also. With that, I'm going to turn it over to Paul Costello, the city engineer, just to go over a few things, and then we'll get into the presentation.
Thanks, Dave. Pleasure for me to be here. I just want to thank all you guys for showing up tonight. At the last public hearing, we took away a lot. There were a lot of comments. We were presenting a large project, which is 8,000 feet, to a large room full of people. We realized that everybody along that stretch of the wall might have different perspective, both in terms of the wall and drainage and a lot of the other things that we were talking about. The one thing I did take away, first thing, which was Mike's quote, he said drainage, flooding, and wall. We all understand that the areas along Adams Shore and Howes Neck have flooding issues. that occur regularly, much more regularly than water going over the wall. So we met with Ty and Bond and we talked a little bit more about going back and revisiting some of the drainage ideas that were in the original plan. And this is a copy of the revised drainage calculation, just to give an idea at the extent of work that's been done. And this report was done prior to the last permitting. But I asked him to go back and revise the drainage aspects of the wall. Now, this is not a drainage study for all of Howes Neck, but we realized that the outfall pipes that go through the wall are the outlet point for that whole stretch. Many of those pipes were designed years and years ago for about a 10-year storm event. So, you know, you get 10 years storm event, back in the day might have been a couple of inches of rain, it would flow through the wall. We all know we're getting a lot more than that. So, this is a map right here. This is called the sub-watershed map. So each of those drainage areas, based on topography and runoff and so forth and so on, this map right here. The reason why we're meeting with smaller groups is because there's these drainage areas right here that flow into the tide gates and the outfall pipes. There's very specific needs and issues associated with each small group. So that's why we've asked you all here tonight, and Dave has broken up this section of the seawall based on the different sub-watersheds. So this neighborhood, you guys all collectively know those outfall pipes and tide gates, probably 3 or 4, I think there's 14 along that whole stretch. So we're meeting with small groups to talk about 4 or 5 outfall pipes. And Ty and Bond will get into very specific information. They've done a lot of calculations. So the goal, and Dave, Ken will correct me if I'm wrong, the goal is to increase all the outfall pipes to handle a 100-year storm instead of a 10-year storm. They can increase the size of the pipes, we can increase the slopes of the pipes. That all gives the pipes a lot more capacity. The outfall pipes, the ends have all been found. We clean them out on a regular basis. Sometimes the tide will come in and push sand back in there. So these guys are fully aware of all the existing conditions and how best to fix it. So if we're going to upgrade those pipes to a 100-year storm event, we may as well do it before they build a wall on top of it. So if you have a pipe that might be 12 inches in diameter, these guys want to make a 2-foot diameter, we have to do it before the wall goes in. So a lot of the drainage, some of the drainage concerns that you had at the last meeting, they've been addressed. The second thing I took away from the meeting was access along the wall and through the wall. Dave and Ken have developed very detailed plans on the different access points and added some public access through the wall, and they revised the detail. So we looked at several different cross sections for the details, and these guys will get into the specifics. But that red that you see right there, so it's largely going to be the shape of the seawall that's there now. We're just going to bring it up a couple feet, but it'll be that same mass. Okay, so the access along the wall that we spoke about at the last meeting wasn't as high a priority as this detail. So again, from the last public meeting, we heard a lot about drainage and flooding. We heard a lot about access. And we've tried to correct it in the revised design. So with that, I'll turn it right over to Dave.
Thank you. Just one, and I know, Dave, you're gonna cover this, but Paul put up that diagram too. Today, as I said, we started early, 9:30 or so, 10 o'clock, and went pretty much the stretch all the way up to Mike Carter's house. But conversation was back and forth that the design going up 2 feet, and Dave Murphy will touch on it a little bit. We can also talk about making the design so that an additional 2 feet can be added if we have to go there. So that's going to be a little back and forth conversation, because I know folks, some areas we're saying, hey, we want to go higher. We realize that we're on C Street and the houses between the Willows and Shoreside, you go up 4 feet, it's awful high. And, you know, if you're down in your yard, you're facing the wall. So we talked about that today, Dave, and I just wanted to make sure that we're still going back and forth a little bit on height and options. And again, the concrete hasn't hardened yet, so we're still back and forth. And sorry, Dave, but you got it.
Thank
So
you.
this is the, really, see, Dave will go over it, but this is the green here, that's the height of the existing wall. At the last community meeting, we talked about coming up this high, if you remember that detail. Instead of coming up to 4 feet, we're gonna come up 2 feet. And Ty and Bond will design it so that we'll be able to add to it in the future, if need be. Okay, so I'll turn it there.
Thank you. If you guys don't mind, let's just sort of sit down, keep it formal. Just for background, just for those that weren't at the last couple of meetings, Ty and Bond's about 400 engineers strong. We've been a New England based firm, we're employee owned, and we've been around for 107 years. Every project that we have is a principal on it, a principal of the firm, and a project manager. So Kenny and I sit here, I'm the principal, Kenny's the project manager of the firm, but there's a large number of folks that you don't see here tonight. Geotechnical specialists, hydraulic engineers, coastal engineers. There's a large component of folks that are on our team that we consult with all the time as we proceed forward. When we started the job a year and a half ago, one of the things that we knew right from the beginning was this is a complex permitting job. These details of design are not as robust, not as how this is the right word, are not as intense as the actual impacts on the resource areas along both the salt marsh on the inside and the resources on the ocean side. So a lot of the attention we have to give up front for the first year or so is with each of those agencies. And they push back extremely hard on any shellfish habitat, on particularly any impact to the resource on the ocean side. To the point where the Coastal Zone Management, Chapter 91 program, the EPA, Army Corps of Engineers, DEP, all of those different agencies together, each one has their own, how do I put this, mission, and their regulatory program is very specific to what they do. But when you put all 5 and 6 of those together, it gets complicated, and sometimes they even contradict one another. Or clash with one another to the point where you have to work those things out. So there's been a lot of history leading up to even getting here. And we've been very successful working with those agencies to both minimize the footprint impact and also to work with to get the best outfalls allowed on the site, and to work with the tide gauge structures to have those be able to be permitted. There's a lot of stuff that can be proposed that is not permittable. And we've got to the point where now we have a green pathway, a green light to go forward. That said, moving forward, as we've gotten through all of those permitting agency meetings, we were able to submit a set of plans to start the whole process, but we created a basis of design report, which set, how we were going to, what the footprint was going to be, what the impacts are going to be, what the outfalls are going to be, how we were going to, penetrate through the walls with each of the pipes, identifying every one of the drainage pipes along the way. And we basically got to what you saw before. The actual design itself, when you get into the details of the design, come on, how is this going away? There it is. We specifically went into the details of the wall that we're going to in a minute, the stairs, the outfalls, impacts, materials of construction, each one of those, visual impacts, and certainly how do we deal with sea level rise, how do we deal with wave overtopping, how do we deal with eliminating to the best extent possible what you guys suffered through in March. In the middle of the design and permitting, obviously the January storm came along and the March storm came along. Commissioner Grazioso and the mayor asked us to be part of the whole emergency response. So Ty and Bond, working with the Department of Public Works, led that, and we had, well, I don't even remember how many construction contracts and crews. So the 4 of us sitting here at the table oversaw, I think at one time we had 10 or 12 construction crews simultaneously working on the walls to rapidly try to restore what you had out there, just so that at least between the time the new one is built and now, we were able to get those all done. And hopefully people saw that activity and saw that work that occurred rapidly. And I think that we, as we saw today, the visual observation of all those repairs, hopefully you guys have all seen those and enjoyed those to some degree. Let me move into the wall cross-section, because there was a lot of pushback from the last meeting, particularly as it related to the configuration of the wall unit itself. And in particular, Ken, if you go to the GIS for a moment, particularly the stretch from the end of the Willows, right, that first house, from that point there all the way through to the end of C Street as you almost enter into Post Island. So that stretch, those homes, or your homes, and as you scroll to the right, Ken, keep going all the way, right where the public access comes through. So that stretch of C Street, access behind your homes, we heard loud and clear that there was not a desire to promote or in any way encourage access behind your homes. So that the configuration of the wall doesn't work in this section at all. And it was very loud and clear. And if people have a different opinion, we'd love to hear it. But I think that's what we heard. We understand people walk along the top of it's about 18 inches wide on top of those blocks. Right now, people do walk on that, but it doesn't encourage access. The way the new configuration of the wall that we had last time did tend to encourage additional access, so we heard that. So what we're, as we've gone back through, the other piece that was loud and clear, and I think I heard it from several, the visual impact of folks that had, on your first floor in particular, or your patios, your ability to continue to have the views that you have now were of concern. Obviously the flooding was a concern, so you want to address the flooding, but you're also concerned with the visual impacts. Right after the storm, the mayor, and we were at the point right after the storm, but we thought that a 2-foot increase was okay, but as we got further into the storm, after the storm, people started saying, well, can you go higher? So we did do an assessment of the existing revetment design, and based on the revetment and the ability to put a 6-foot wide concrete block on the top of that before we built the wall higher, we went through all the calculations, we knew we could go up 4 feet above what's there now without compromising the design. Otherwise, if we went higher than 4 feet, we would have had to either double the cost of the wall or go wider, which the permitting agencies wouldn't let us do. So we're in the constraints that we have. We can go up as high as 4 feet above what is there now, with the existing design staying within a reasonable budget. So back and forth, back and forth. Ken, if you can zoom in on the top left. This is the existing cross-section. We call it a curved face block. It's the block. There's 2 of those in the city. One has kind of a gentle curve, another one over on, I think it's Squantum Street, going on to the Squantum, that has a more defined curve to it. But there are 2 separate blocks that are in existence in the city. That's one of them. We'll decide on that in a few minutes, and I'll explain that. That's where you are today. So just for clarity, elevation top of the wall is average 11.2. That's NAVD data. Mind you, be understanding that some people don't get confused, because there's a 5.2 or 5.4, 5.5 foot difference in some of the datums. So always be careful which datum you're working off of. So tonight we're only going to use NAVD 88. So the top of the existing wall is 11.2. Mind you, the annual high tide is 6.9. The annual. And your mean high water is 4.7. So just understand that height difference between the top of the wall and your mean high tide here in Hotel. What we have talked about at the last meeting was going up to elevation 15, about a 4-foot increase. After all the feedback back and forth, the city's come to the decision that right now we're going to move to a 2-foot increase with the ability to go to 4 foot. So right now the plan is to move to a 2-foot increase. And Ken, that's the 2-foot increase right now. That's taking the top of that block up to NAVD 13. In the discussions we've had internally with the city, it's a compromise. It's the ability to, if we did a 4-foot increase up to elevation 15 today, that effectively is a 75-year design, maybe a 100-year design life, the life of the structure. But by going to 13, it's a decent design today. It covers today's wave action. But we know, as we've discussed, and many of us have discussed, we know that the sea level rise is upon us, and that we're going to see some of that. So having the third option, where we're headed, Ken, if you flip to that one, this gives us the ability to take a 2-foot block, and the way we're going to design the lower block, the the low block. We're gonna design it so that we can put either an 18-inch, or 1 foot, an 18 or 24-inch extension on the top of it, similar to what was done in Edgewater Drive back 15, 20 years ago. So that's kind of where we're headed right now, is that block design with the ability to put the seawall extension block on top of it. That is a balance between the blocking of views and, trying to address the long-term, rise in sea level and ability. So we believe that the 2-foot rise will eliminate the majority of the wave overtopping for a storm like we saw in March. There'll still be water that'll get over, but it'll be more the splash as opposed to a heavy volume of water that'll come over.
This is a reminder, the storm we had in March got up to elevation 9.5. So Ty and Bond is proposing coming up to 13, which is still 3.5 feet above that high tide we saw in March. So we're dealing with a wave action at that point. So if the wall was at elevation 13 this past March, a lot of the flooding would have been, taken care of.
And I think too, as we strolled around today on the wall, and we realized this a couple of weeks ago when we all had a meeting up at City Hall, how close the houses are to that seawall on C Street, till you get to Post Island, you get a little, a little loop there. But also, as we walked along, we talked about the other side, the marsh side where PJ is, to say, even though we're gonna come up and protect this a little bit better on the seawall end, with the proper drainage and Dave will talk about that also in the seawall, but we also discussed the other side, because the other side also, if it gets over, as a lot of people know, it's a very low point at the boardwalk, and to get it out of there, then we have to have good drainage too, but, so it wasn't just, I just want to reiterate to anybody, and I know I'll probably hear it, what about the other side, what about the other side? The other side is on our radar also.
As Dave said, we'll take care of what's happening today. There are projections for sea level rise. You read about it in all the newspapers. Scientists have different opinions on what that will be. So we've asked Ty and Bond to design a wall so that if we need to come back in the distant future or the near future, you'll be able to build a wall up to elevation 15.
Now, one thing to be aware of, the cross section that you see right there with the extension, the width of the top of the wall will be actually a little bit wider than the width that you see right now, because we need to make that block a little beefier on the top to take the extension. So you have about an 18-inch width on the top. It's probably going to grow to, we haven't, the calc isn't finalized yet, probably closer to 24 inches. So that you'll be up 2 feet higher, but you will be able to have the same width of walking space. Not that we want to encourage people to walk, because there's a liability associated with it, to the point where, Paul, you may have suggested today that we put signs along that wall, no trespassing signs along the wall, so that to discourage people from walking along the wall. So just be aware that it's a figure there, that's not an actual final design piece, because that is yet to be done. Any questions? Maybe we open it to questions now, before we go to the hydraulics, because that'll be the next major piece. Any thoughts?
That's good, I think that's very good.
I think it's good, but not good enough. I think, for one thing, looking at the extension block on the top, there's no wave return to that. I think
that can be built in. We can, it's just a figure.
In that section, okay, but I feel like, when we're saying things like, this is what we have right now, we need to be looking 50 years down the road and 75 years down the road. Let's face it, the seawall that's there now was put in basically around 1955, okay? Things have changed drastically, and it's going to continue to change drastically. We've dodged many bullets. January 4th, all our neighborhoods would have been flooded along C Street then, except we had a seasonably cold January, so there was ice on the bay. That saved us. Parts of Germantown, parts of House Neck got flooded then. I think, and again, the ocean's coming back. I've lived there almost all my life. Everybody who has said they've never seen anything like this, and we've all lived through blizzard of '78, no-name storm of '91, numerous other storms where our houses have been surrounded, C Street's been cut off. I think we need to go for the absolute most we can get, because, you know, this project's not gonna, this isn't gonna happen probably for about 2 more years, okay? Realistically, when all the studying has to be done. And again, I'm not, we're all working cooperatively on this, but I think we need to look at the really big picture here, and not, you know, if it costs more to live there, fine, as far as I'm concerned. Because we're protecting the place that we are living in for as long as possible. I think that has to be our priority, you know, for ourselves, for our lifetimes, you know, for our kids, for our grandchildren. And this is also to prevent, ultimately, you know, when C Street gets cut off, we were super fortunate with the city's response about evacuating people. We were incredibly fortunate that no one was electrocuted, drowned, you know, during that storm, during the evacuation. If there'd ever been a fire down House Neck or on Post Island, you know, we would have gone from property disaster to human catastrophe, which you see, and it's happening all around our country.
Can I ask what address you're at?
Yeah, 5 Post Island, yeah.
I think it's important, I think Ty and Bond has done a great job with the revised design.
Yeah, no,
We're trying to balance
Yeah.
between needs. I just want to put these in perspective. So the current wall is right here roughly, okay?
Yeah.
If we do the 2 foot to handle the storm we just had, wall's coming up to here.
Right.
Okay, so aesthetically, some people with their views or whatever would think this might be too much.
See, and I get that, I understand that.
If we came up to elevation 15,
Yeah.
it's built up to here.
Okay, my home is one of the lowest ones, and it's in the process of being elevated.
Right.
And I had, you know, $250,000 worth of damage to my home, okay? Again, been through lots of storms, and I think for some people, it's gonna be the choice between, do you wanna have a view for a while, or do you wanna have a home for the next 25 to 50
And
years?
all we're saying,
Yeah.
Mike,
Yep.
is that build this, see what people think about it, live with it. And we can come back and do this. If we build this today, and people don't like it, you're stuck with it.
True.
We have to take it down.
But I
That's
no,
why I
no,
think Ty and Bond is.
you'll never take it down. The ocean will take it down.
Other thoughts?
Yeah.
Curious, any other responses?
But I think we ought to emphasize the solution to the flooding is to how to get rid of water. I mean, you can build it up as high as 15. From my picture, I see the wave overflowing 3 to 5 feet from the current seawall. So stopping water flowing over is a temporary solution, it's not the ultimate solution.
So Ty and Bond has been working to increase the pipes, and so on. And we're also talking to them about pump stations, pumping.
Yes, I personally would like to advocate, get some emergency things like a, you know, fire ready, like a fire hydrant, that type of thing. When you have a storm, you activate everybody to get them out and pump the water out. You know, starting from 6 inches deep, start pumping out. So I think that's a better solution.
Exactly, so
We'll go through the hydraulic stuff, but just hold on, let's just, if you don't mind, just hold the comments and focus more on the wall height and the access at the moment. And then we'll jump into that real fast, we'll go right back.
Just a quick question, addressing his concerns with the 15-foot wall. Where I am, 300 yards down the beach, you get much more wave action coming over the wall. I don't get that in my house, and I didn't at the last storm. I have video of it. I got a little bit of splash over. There was about 6 inches of water in the yard, and then an hour later, after high tide came in, that's when I got all the flood coming up C Street. So, like I said, a 15-foot wall just doesn't work for me.
Well, we chatted about that, and again, this is all hypothetically as we make our way through this, but to leave it 2 feet high from the willows up to about shoreside, till you hit the bend where you get the grass right at Charlie Cote's house, that elephant house. Then talk a little bit about raising it up and running it to Danny Shea's house, or down to that area, before you get to the Shelton area where you know it's gonna go up again. But again, we're kicking it all around to make sure we don't commit to something that we put in that is gonna be too big, or I don't like it, or, you know, it still doesn't work, and so we're kicking around. But one of the big things, Mac, today we were talking about was, you know, where your homes are, and they're beautiful houses, but they're right on top, is that, you know, we were looking, every time we said 2 feet or 4 feet, you know, we looked at the picture window, you know, people would probably think we're looking, you know, in their houses all day, probably get reported. But we were looking at that, saying, okay, there's a guy who, I don't know if he's here tonight, the guy who was constructing that new deck. You know, there's a new deck on the back of a house, it's just some studs. And we said, this guy right now has, you know, even though he's doing it, is perfect in regards to if we raised it, he'd be above it. There was some that were gonna be, that'll have to be changed, but that was the thing a couple weeks ago we got into when Dave was being very realistic, saying, okay, we go up so many feet, you know, we were all using the wall as a guide, saying, you know, the wall was gonna be, you know, this high or whatever, and you're gonna be sitting in your backyard not seeing a thing. And some folks have said to me, we're on the water, we realize when there's a storm, we're there. So I think the approach is kind of the 2 foot, 4 foot look, a little bit back and forth in regards to the wall, so you don't lose that at your house.
Exactly.
You know?
I can see it, a post island needs a 15 foot.
Yeah.
I can see it, when it's not even close to my seawall, it's going over the wall.
Yeah,
I mean, big waves going over the wall. Like I said, it's not a one size fits all, even 300 yards down the beach.
and we
Can I
all,
ask everyone to just say what the address is, so it just helps me.
668C,
68,
668.
668.
and Dave, that's more down towards Shoreside. But we kind of had that same conversation we're having here, which is good, back and forth all day this morning, talking about the C Street, talking about Post Island.
One
You know,
thing
back
I
and
want to
forth.
just say, and I don't mean to scare you anyway, but this particular storm had a particular wind direction and wave fetch coming in, and it's not going to be the same for every storm. You know, so we can't always assume that you're never going to get hit. So that the part about the design criteria that we have to go through is to in all storm assumptions along the shoreline. And, you know, sometimes, you know, PJ's hit right across from C Street, sometimes that can hit hard. It might not get it the next time. You know, it might be more concentrated on Post Island, it might be more concentrated in your house. So just take that into consideration as you think through, you know, kind of what we're proposing. Other thoughts? There's other people in the room. Please, in the back, in the back.
Oh, so has the increase in width been completely taken off the table?
Increase in width.
The wall? It's gonna
Well,
stay
if
the
you go
same.
back, this stretch right here, you mean the width as you look down the wall?
Yeah, like to walk along.
Are you talking about that small section we had up before? That little,
Yeah, they were talking about increasing the, like to walk, if you're looking down at the beach, walking along the wall.
This one here that Paul has hand, I
Yes.
don't have it overhead. Well, yes, we've actually, as the feedback that we got from the majority of people in this stretch of seawall was they did not want this access.
Okay.
So that's effectively taken off for this stretch, no question.
And access along the wall is taking a low priority compared to drainage and.
So just for clarity, that piece there is what, can you go back to the actual proposed? That's what's proposed. See this where it says 6 feet wide? That's basically a concrete leveling pad. So we'll be pouring about a 2 foot high. Right now you have a 4-inch leveling pad. That'll all come out. We'll go up to 2.5 feet, and then put the block on top of it.
Okay.
But there will be, you know, about 18 inches to 2 feet wide on the top, but 2 feet higher. So, you know, you can walk on it, but it gets more dangerous because the fall is greater.
Right.
You had a question?
I did have a question. I noticed that,
What number house again?
789.
That's right.
I noticed on the NAVD 88, you go from 12 to 15, and you go in the middle. Was there any consideration for somewhere in the middle of that, splitting it not 2 and 2, but splitting it, 2.5 and 1.5?
We had 1,000 discussions.
You did. All right. All right. So you're not centered on the 13. That was kind of like this is the majority.
The 13 was, we don't want to go below 13 because we
No,
have
I
to
know.
address the
I
wave
know,
action of
yeah.
today and some anticipation of increase in the
Right.
near future.
In speaking, in addressing this gentleman's comments, 13 something, maybe 14, and then something on top of that later. And the second part of the question, I'm not looking for an immediate response, by the way. And the second part of the question is, again, addressing him, is there any guarantee that the money will be available to put that 2-foot block on top? I mean, that's all nice to talk about it, but.
Well, do you want to speak to the availability of money right now?
We're talking about the
You
2 foot
won't
on the
even
other
know.
side.
He's talking about the future.
Yeah, future. I mean, I don't think that's a guarantee. I think they'll, I mean, you know.
Oh, you mean the 2 to make it 15?
You bet. I mean, I can see in 15 years, you start talking about it, and the populace of the city saying, come on, how many times are we gonna do this wall?
Dave, in a percentage-wise, like, what, adding that cost-wise,
It's certainly not gonna be, you're going up 2 feet now, it's not gonna be the same as going up now, because the majority of the money is gonna be in the leveling pad, and resetting the refatments, the
So
pipes.
you don't have to answer it now, I'm
But
just throwing it out.
it's not a high percentage of the cost that we have now to add 2 feet.
So you think that, well, there's probably a good chance that that money could become available, if it was determined after study and study.
I'd say if you got a couple more, you
Yeah,
got a couple more good examples,
if you,
2 feet would go up pretty quick.
if these seawalls didn't work, I think that the outcry would be,
Yeah.
But there's damage before you get the
Yeah,
outcry, so, I mean, the
Yep.
idea is to avoid that. So I don't know, maybe a consideration is you stretch the 13 a little bit.
Yeah, and then you could go up to 2 to 15, and
I,
Mother Nature again might not
I
care
don't
about
know.
that
I don't
at
know.
all. you know,
I'm
so-
anticipating a response over here, at what number C Street?
664 C Street. I am really pleased with this design compared to what we've seen previously. I appreciate the fact that there's flexibility for future. The 2x2 block is seemingly going to be nominally expensive if we ever have to get to that point. My understanding is that what you're projecting is this lifespan of this wall is 75 years. My understanding from FEMA is that flood rate is going to potentially raise another 2 feet within the next 100 years. So this seems like a good approach, especially for this stretch of the neighborhood. You know, we do say, you know, Steve and I have had several conversations where Post Island is a different animal. Even around the bend at C Street, Manette, that's a different animal. Because of the way the winds hit, the wave action happens. So I really appreciate taking the time to look at this sort of micro environment. And that I think it responds really well to the current condition, the projected condition for the next 50 years, and gives us the flexibility to provide further protection for the long term. So I just want to thank you for taking the time to look at this.
And again, we're meeting with each neighborhood separately as we roll this out. So Post Island folks decide that they prefer the 15 because the houses are set back and the views aren't as intrusive, then.
Well, and then they have a completely different wave action issue than here. We're largely protected by the bay unless there's this really weird wind direction that happens, and time that with, or, you know, pair that with some electronics not kicking in and some drop inlets being bricked up. That's what sunk us. To reiterate what Steve said, we didn't flood until 45 minutes after high tide. The issue wasn't the waves. The issue might be the waves someday, but we still had, the waves came up a third of the height of the wall where it exists now in that terrible storm. So having 2 extra feet will make me sleep better at night when I know that there's a gigantic moon outside and the nor'easter's bearing down on us. You know, maybe I won't sleep on the 3rd floor, I don't know. But I just want to thank you.
I think the compromise would be maybe in the Post Island area, you put the 2-foot blocks in now.
Yeah.
And just build up that section, but to the 15 feet.
Can I comment? I like the redesign that you're proposing right now. And I personally think that elevation 13 is good enough for now, because the goal is how to handle the water spilling over. It's never to stop it from flowing over, because I believe you go 17 feet, you still have water flowing over because of wave motion. The key thing we should emphasize and where to spend the money is how to address the drainage. you know, the water. That's a key thing.
You're absolutely right, so.
We'll get there, we'll get there.
Bringing the wall
I
down,
mean, so the money should be, put more emphasis on how to get rid of water.
right, so bringing the wall down a couple feet.
No, 13 is fine. I'm
These guys are
happy.
gonna talk about the drainage, but they're talking about pump stations and so
Yeah.
forth. So,
Let me just make a comment about, if one section of the city neighborhoods wanted to go up to 15 today, we would probably not add the extension on the top of the block. We'd rather the leveling pad would be poured, cast in place, poured right there, would be poured at 4 foot high, and then put that same block on top of it. So the top section of the wall would look like that, as opposed to, it's an easy way to do it, just so everyone has it. I had it, there was a hand over here.
Just a quick question to it. I always go, instead of, you know, the nav, you know, 88 and all that, I go by the high tide, okay? The high tide in Boston Harbor is 8 foot, or 9 foot, or 10 foot, or 11, or 12. So what we were talking about back in January and March this year,
That's on the other data.
15 feet, okay?
That high tide you're referring to is the other data.
mean low water.
That's mean low water.
So, but what it is, it's
So, you know, you have to subtract 5.5 feet to get to these numbers.
It's-
15 minus 5.5 is a 9.
Sure, you know, engineering wise and all that, I get that, but what we live with is the tide's either 10 feet, 12 feet, or 15 feet, and we got a northeaster blowing it, you know, with gusts of 50 or whatever. And what I'm not hearing is, so what's the effect of the tidal surge? You know, beyond the tide itself, we have this huge mass of water, you know, building up out at sea that comes in all of a sudden, as it did, you know, on March 2nd. It's blocked somewhat a little bit by the islands, and yet we still got the kind of flooding that we did. So absolutely drainage is a huge piece of this. But you know, that's what I listen to. When I hear the weather report, and I think most people do, you know, if you're a sailor, if you live on the water, you know, the height of the tide, it's 10 feet, 12 feet, you know, if it's a flood tide, it's 15 feet if it's a monster coming your way. And then there's a surge on top of that, okay? So
just to speak to that for
Yep.
a minute, and again, if Duncan were here, he could speak to exact science, because he's been doing it for 35 years.
Yep.
The actual annual high tide of 6.9, we had the worst tide, you quoted it as 9.9.
9.5, which 5.5 datum is that 15 number you're talking about. So we're talking about the same thing, just different datum.
expressed differently.
But that's a static high tide elevation.
Right.
That does not include the surge. That's why the wall has to go higher than that 9 in order to account for that 3.5 full foot surge. And that's why it's critical that we get up to at least elevation 13.
And that allows for a 3.5 foot surge. In the outer harbor, the surge in March was about 20 feet. By the time it hit the coast, it was 3.5. So that's
So that assumes the worst case annual high tide plus the surge. All right, any other questions on particularly the access and the wall configuration, please?
Quick question for you. The blocks that are going up on top, are they,
What's the address to, I'm sorry?
I'm sorry, 11 Shelton Road?
Yeah.
The blocks that are going up on top, are they precast that are similar to the ones that are there now?
Those
Or are they
blocks-
gonna be poured in place?
No, those would be precast.
Okay,
we-
so,
With CSI is one of the companies. that
yeah.
we do it.
Yeah. So my question is, are you gonna grout between the blocks? Or are you not gonna grout between the blocks? Because if the blocks are there and there's a space of 4 inches between them, obviously the water's gonna come through that opening.
The plan right now is that every so many blocks we have in files, for every probably 3rd or 4th block, literally cast into the concrete block mass will be a drain back pipe with a valve on it. So only allows water to drain towards the ocean, doesn't allow the water to come up from the ocean in. So that the blocks will be grouted in between, so there'll be no ability for the water to go through the block. It'll be
But that's
grouted.
every 3 or 4, there's
But every
still,
3 or 4, you'll have a drain back pipe. To accomplish what years ago, the design used to, they didn't put grout in them.
Right.
To allow the water to drain back.
so if you look at, say, Palmer Street down in Germantown,
Right.
that flooded because they didn't get any wave action. The water actually came through those openings between the precast blocks. If we have the same issue on C Street and the water comes up, that water's gonna be coming right through that opening between the blocks.
We will grout the blocks.
Okay.
Right after the last time, we went back.
Yeah,
about
yeah.
$500,000.
Right, but on Palmer Street, it's still the other way, and that's still an issue for them. Those blocks really should be grouted to prevent Palmer Street from flooding.
We're almost about an hour in, so just any other comments on stairs, on wall configuration and heights?
I have the design very good,
Those
but
are the interesting.
yeah, 3107.
This is about C Street.
Yeah.
The designs of the wall, of the seawall right now is look very good compared to the previous one. But do you have the dimension of the old and the new? Dimension of the old and the new. Can you insert the dimension of the old seawall into there? And
We actually
also,
have a figure that shows the overlay of one on
you have
top.
overload it.
His overlay from the previous one versus what.
You don't have it up there, Dave? You
No,
don't?
I don't.
Yeah.
Ken, I don't think we have it on file.
Oh, this is, so you know, two people up and down.
Yeah, sure, we can. You read it.
Yeah.
I'll leave it.
Yeah, the goal with the blocks themselves,
And
sorry, so the goal with the blocks themselves with dimensions is, like Dave said, is to try to keep them aesthetically looking to what you have today. Obviously, these blocks have fared, for the most part, fairly well over the last 50 years or so. You know, with the exception, what we've seen is even some of the newer blocks that were put in 20, 25 years ago aren't holding up as well as the ones that were installed 50 years ago. When we did the repairs over at Edgewater Drive about 5 years ago, we paid a lot of attention to the manufacturing process for those blocks, and we really pushed back hard to make sure that it was a high-strength concrete, to make sure that these things are stable and will last quite a while. So from a dimension standpoint, they're going to be very similar. You might see a little bit of an increase, as Dave said, as to the sort of the width. Maybe now they're at 4 feet deep, 4 feet tallish, 7 foot long. Probably going to be about the same, just from a shipping and manufacturing and mass producing these blocks. We're talking about 1,000 or so blocks that would have to be installed along the entire length of the wall.
So if you had to say, what are they like, are they 6 feet deep?
7.
About 7 foot long. If you're walking along the wall, each one's about 7 feet long.
So when you're facing the blocks, they're 7 feet wide.
7 feet wide, about 4.5 feet deep
At the base.
at the base, and then that gives you about a foot on either side. The leveling slab will have about a foot of exposure on either
Yep.
side.
And then the height of the block actually,
Roughly
Is
4
4.
feet, yeah.
The old blocks, believe it or not, all the old blocks were never pinned or doweled
Right.
into the concrete below. That's why you saw some of them sliding over at Shelton, and some of them over at Manning. They actually moved. The wave action was so strong that it moved those blocks. These will all the ones that were put in during the storm, after the reset after the storm, under the commissioner's direction, everyone, if we touched it, it had new pinning and new dowels, so those won't move until we demo them, obviously.
And these ones will have pins as well.
Absolutely.
Correct.
Ken, do you want to take on the hydraulic analysis, go through the existing pipes, the design alternatives for the proposed? Sure. Let us go through a quick, just a summary of this briefly, and then we'll open the floor up again.
Right, so as Dave mentioned, my name is Ken George. I'm a project manager with Time Warm. What we looked at, obviously, as Paul noted, we've heard a lot of concerns as it pertains to drainage. Drainage and seawalls are sort of, very much intertwined. Seawalls as they're designed are not intended to be a dike system. It's not intended to necessarily hold water back. They're designed with revetment that's porous to allow stormwater to flow on either side. So what we're really looking at is, we're looking along those walls and seeing how the existing city's drainage system interacts with the seawalls themselves. So, using the data, the city has a really robust GIS system that tracks and locates all their drainage. What you see here is what we've been using. It's all the city's drainage structures. all their tie gates, you know, the outfall pipes, and it has direct link to plans that date back to the 30s, 40s, 50s. So we're looking at all that data, making sure that it gets updated into our plan set, and looking at all the available data as to what size the pipes are. Some of the pipes that have been in the ground for 50, 60 years, we're looking at plans that are 50, 60 years old. So we're trying to deduct from that data what's out there and compare it to what current standard is for drainage and stormwater design. There's roughly 14 outfalls along this stretch, along the project area. In this area, you'll note that there's 1, 2, 3, 4, 5, 6 or so, 7 maybe outfalls in this area that collect drainage from a number of structures across the road as well. Councilman McCarthy was mentioning, you know, there's some drainage back here. But you'll notice that there's a lot of catch basins, that's what these little black squares are, that drain and collect water that drain towards those outfalls. What we're looking at and what Paul was alluding to was we had part of the city's GIS system allows us to look at the drainage areas for each of these outfalls. So we've broken this down and said, okay, this outfall pipe that's here, it's collecting an area of so many acres. And today that pipe is 12 inches in diameter. Well, that 12-inch pipe pitched a certain way can allow a certain amount of water to flow through. So we're looking at it saying, okay, what is the capacity of that pipe? And after looking at all the pipes in the system, we wanted to recommend increasing those pipes to a minimum of 16 inches. We found some pipes, some catch basins that are discharging using a 6-inch pipe. And going to a minimum 16-inch pipe is increasing the capacity to move stormwater from one side of the wall to the other significantly. That alone is not going to solve every problem because it's a comprehensive plan that the city that we're working with the city to implement. It's making sure the catch basins are cleaned out, making sure that outfall pipes aren't buried with sediment, making sure that they're located in cataloged in the GIS system like this. So the city's got plans in place to do this work, and you can see just from the data that they've collected through GIS that they have methods to implement the changes that we're recommending. So with that said, we're looking at increasing capacities through the system fairly significantly. You know, in some instances, going from a 6-inch pipe to a 16-inch pipe is gonna make drainage better, but it's one small piece of the puzzle. The larger piece is, you know, looking at the areas behind as a whole, doing further investigation to try to figure out on Post Island Road, on Shoreside Drive, where there are low spots, where can we locate either a temporary pump during severe storms, or can we put a pump station, literally a building that fits in with the neighborhood and in critical times of storm surge, that pump can be turned on and starts forcing water outside the outfalls. You do that and you're now forcing water, regardless of where the tide is, that water will start flowing the opposite direction. Catch basins, locating the proper number of catch basins. Certainly, standard that we deal with is generally a catch basin every a quarter of an acre is around what we typically like to put in. In some of these areas, we probably see that there needs to be a few more catch basins put in. And that, by putting those catch basins in, it channels water to those outfall pipes, thus removing stormwater from the other side of the wall. So, yes, raising the wall will prevent some of that splash over, but making simple upgrades and better managing it and doing what the steps that the city is taking is going to make a big difference, I think, overall. So, with that being said, I'm happy to try to answer any questions regarding the analysis that we've done, and I caution that it's an overview. There's a lot of detail that a more detailed, thorough review of this will need, but this is more of a looking at the total watershed, these total areas combined. As Paul said, let's make sure that the pipe, the end point, is sized appropriately to handle a large storm event.
Ken, let me just jump in for a second to make sure. So what we've done initially, we had all the pipes sized up to 16 inches minimum. Since then, we've met with the city officials, and they basically have instructed us to not only go to what we call it a 25-year design life, so a storm that comes back every 25 years. The city has requested us to take all those outfall design pipes and increase those pipes up to the 100-year return frequency on a storm. So each of those pipes, the pipes will actually go larger than the 16 inches, and they'll all be designed to handle that 100-year return frequency storm.
In layman's terms, all time bond did essentially was look at 2 inches of rain over this area, 4 inches of rain, 6 inches of rain, 8 inches of rain, the 24-hour period. And the 8.5 inches of rain is what they call a 100-year storm. So, at low tide, you get hit with 8.5 inches of rain, those pipes will be sized to not have any water flooding. Now, we're all aware that at high tide, those elevations, some of them below the tide level. The tie and bond is looking at what flow will still go out, and the flow that doesn't go out, that's when you need protection pumps.
It's important to, it's important to understand that there are three components to dealing with the drain system. One is you have the rainfall just from a storm event. Put the ocean aside, put the high tide and the waves aside. You have just straight rainfall that every city has to deal with. The normal design standard is a 25-year design storm. So the system will be designed so that the pipes penetrating the wall will be able to handle that flow. The second component is wave overtopping. That's what you get hit with very, very hard. And the third component is the tide itself coming up the outfall pipes that didn't have one-way check valves in them and flooding up the pipe system. So you have overtopping of the wall, you have tide cycle coming up your drainage system and flooding, percolating up through, and you have rainfall coming down. So there's three components. So in this design, we have to handle all three of those components.
It's interesting, the intensity of the storm last week, we got an inch and a half of rain and now it goes back. Town Brook and West Quincy flooded because the rain came down so fast, so quick, it was like a bunch of cars getting on the central artery at the same time. Right after that storm, or during that storm, I drove around Howes Neck and Adams Shore, and there wasn't a lot of flooding because it was that low tide. So the tide cycle impacts the rainfall event.
So please, yes.
How are the
And again, what address again?
53 Post Iron Road?
Thank you.
How are the catch basin tied to the drain pipe? Because last time when I saw it, it was all clogged up. Couldn't go anywhere.
All the catch basins have been cleaned out, everything's been cleaned out. We find the outfall pipes, you might have seen the DPW crews out there. We have a camera, we put a jet in there, and we clean it out. Yeah, a big storm comes in, the sand and gravel dumps up against the pipe again.
How are they connected? How are they constructed? I mean, what's the circuitry between this catch
You go to the
basin
chairs, Ken.
to the drain pipe?
The city has all that in our GIS mapping, so we know the exact diameter, the invert elevations, and so forth and so on. So Ty and Bond can model this pipe network.
Yeah, this for instance will show like a 12-inch pipe. It'll give you information on the material of the pipe. And we've also got, access to the plans from like city engineering department where you've got, it shows you the structures and the original design, making sure that the pipe is flowing from the catch basin. Now, the pipe just goes in and it's sealed up.
Hey, Ken, is this accessible for the public?
So this is
These plans are over on the engineering department.
So this pipe here was built in 1954. Here's the seawall. Here's a catch basin or manhole, same here. The pipe comes out at a certain slope, it's a certain diameter, which dictates the amount of flow that can leave. So you can see at low tide, the water will just flow out to the ocean. The tide starts to come in. Then the pressure of this catch basin, the water, it's like a straw. The water will tend to do that. But if during the storm, it comes up here, then the water switches from here to there.
Oh, it won't go anywhere.
Bob, can you explain?
So there's the hydraulics behind it all, which is, this report here explains each one of these outfall
So
pipes.
just for clarity, if you have a high tide at the normal high tide is at 6 or 7. The drainage structures are up in the 10, 11, 12, or 8, I guess 9, 10, 11. If there's 2 feet of head difference, if the water up gradient is above the tide, it will still flow, even though the pipe is, fully in water. The head pressure difference will allow that water to keep flowing. It just gets reduced some. So we're working on basically trying to figure out what the reduction in that flow is under different tide cycle conditions.
So I know that is the problem.
Sorry,
Sorry.
just for clarity. You
Yeah,
had your hand up for a
I was
while.
curious, are the drainage structures, are they flowing into the marsh at all? Do any of them outfall into the marsh itself, or do they all flow to,
So right now, not in the houses back here.
But what
They
about-
all flow towards the ocean.
what about the marsh
This
behind
marsh
Post
here,
Island?
you do have a couple,
Has there been any discussion about rerouting them from flooding the marsh, from basically surcharging the marsh and directing those pipes into the bay itself so that all the other water that's needing to find a place to be can rest in that marsh? Because I have a sneaking suspicion that if you're surcharging the marsh with drainage that's already in a structure, you're sort of artificially flooding the marsh when we need that capacity for drainage.
We have talked about the marsh is the low spot
Right.
geographically. We have talked about pumping out of the marsh, so to make room for the water that's coming in. So we have looked at the marsh. We have to be
Okay.
careful because the marsh is, as Dave said, is also a wetland resource area.
But that's where I would think that Concom would be pleased that we're not discharging
Right.
our sewage, well, not sewage, our
Drainage.
drains into the marsh to allow the natural ecology or the rain or whatever is splashing over the wall
So
to land in the marsh.
We'll steal some thunder for next week's Post Island Road.
Okay,
As we look at that marsh area, you look at, we have to increase the size of the outfall pipes. We have to increase the size of the seawall. In the area there, the tide gate has to be replaced. We'd like to go to an automated tide gate, so it has what we call SCADA system, so that it can be automatically handled. And Paul has led this charge of, working towards analyzing all the hydraulics, and looking at all the catch basins, looking at all the drains in the area, and determining where to put a pump station, a permanent pump station, that would open if a high tide is coming, we know it's coming like Blacks Creek, we shut the tide gate, don't allow that high tide to come in, and basically we have a backup stormwater pumping system right there in that area at the low point, so we can turn that on in the event that we have overtopping of the wall. It wouldn't be stormwater, it would be overtopping of a wall that we'd need it for, more than likely. So it's a combination of multiple things that Paul is basically working with us to put in place. Other comments about drainage?
What is GIS, by the way?
Geographic Information System.
Okay.
The city of Quincy has a company called the People GIS, and by the middle to the end of November, a lot of the GIS maps are due.
And it has in it, so in the GIS layers, you have every layer known to God in there with the information. You can accumulate just a tremendous amount of information on every single pipe, every single catch basin.
and there are 2 separate GIS, so the city, the tax assessor's map, the general public has access to this map here, which is, if you're interested in trying to figure out relative property lines, relative public access points, relative who owns what parcel of land, this is the system that's on the city's website. It's a similar system, but it's obviously used more, the DPW has at their disposal for tracking various
So
daily operations.
Christmas Eve last year, the week before Christmas, we reflew the entire city, and we received 1-foot topographic information, so it's highly accurate. In every catch basin and manhole, we can locate plus or minus a few inches. We've overlaid our utility system, that was in a different system, overlaid that onto the flyover. Then we've taken the assessor maps, put it on top of that. So we have one system now that has all of our GIS system together.
Is this something we can access, public access?
We will be, we're still working on the system. We hope to have it up completely in sometime November, December.
In the back?
Yeah, do all of these pipes terminate at the wall, or do they extend it to the beach?
Some do terminate behind the wall.
Behind the wall?
Yeah, years ago, I think, and as I mentioned, sort of, the walls themselves are not meant to be impermeable and not like a dike system where it doesn't allow any water to flow. So a lot of the drainage systems, or a few of the drainage systems that we saw, are a pipe that just extend to the backside of the revetment, and that's it. They were
Under the
labeled,
wall, through the wall, and drop into the stone on the ocean side.
so they were labeled as dry wells, and for years they probably functioned fairly well, but as storms get bigger and the area gets built up more, it becomes less and less able to function and carry the stormwater out. So this design that we have is really taking those, daylighting them, and making sure that they discharge on the beach, but have, as Dave said, a check valve in there to prevent water from rushing back up. The ones that are currently behind a wall, buried or pointed towards the back of the wall, don't necessarily have a method of preventing water from coming back in.
And the check valves will all be installed in new structures on the land side of the seawall, so DPW crews can go down to that structure and access that check valve easily and maintain it, as opposed to being out in the water where they can't get it. In the back, PJ?
Just to that point, this is great, by the way, Dave, I like this format very much, thank you. To that point, I'm sure that when we replace the existing pipes with the larger ones, they're gonna follow the same path, pretty much, I can see that.
There's some exceptions.
If you
One thing your
have,
house is gonna be changed.
well, if you have a little wiggle room while you're putting in something new, in one of your earlier graphics, the photograph showed out that series of jetties that run all the way along the shore, all the way along. And they're doing their job. They're building up that beach on the windward side, and a lot of the outfall pipes are on the windward side. If they're on the leeward side, there goes a lot of your sediment buildup issue.
Not allowed to build them anymore, unfortunately.
Well, that's what I was wondering, but,
Wish you could.
yeah,
Regulations will not allow.
because the one in front of my house is where it discharges on the beach, it's up high enough that it really, the sediment doesn't, it's just an open pipe.
Just a quick point on that, PJ, when we started down past your house this morning, and we made ourselves up checking the outfall pipes, we all agreed that, probably there's, as the wall goes in, there was a pipe that's elevated a little bit down to the right of your house, and then all of a sudden in front of your house, there was a pipe that comes kind of at an angle. And then after that, we could see that, we went a distance before Ken brought up the next outfall pipe, and say, so strategically, I know that Dave and Ken and Paul are gonna look at additional outfalls, in spots where we know where it ends up and it kinda stays there, like in the Willows area, where it comes over and maybe has a hard time getting out. Maybe we can do something more right there on the corner to get it out, in regards to outfall. Up by Matty Lyons' house, it kind of dips a little bit. Then you have the hump at Post Island Road on C Street, and you go down into the gully at the marsh, So we were going back and forth, just strategically talking and kicking around ideas to make sure that we had adequate outfall also in this new design.
No, that's great, thank you.
One of the things that came up, I'm sorry, you can get this.
Real quick question, if you put a pump station in, where are you gonna pump that water to?
The ocean.
So the goal behind the pump station is, as Paul said, is when you have, say that this were a pipe and this is the outfall, and the ocean tide generally and low tide is out here, the capacities that we looked at, the amount of water that the pipe is able to freely pass, really the maximum is when the water's way up here. When that tide comes in, as Paul said, we're looking at what is the reduced capacity, because it's going to have a harder time getting that water up. When you put a pump station in there, the level of tide shouldn't play into that decision. You could, in theory, push that water out, much like, a fireman's hose underneath the water, you'd see that water rushing in.
So you would pump it out through the existing outfall pipes?
Exactly, and regardless of sort of regardless of where that tide is, if you notice that there's significant water building up behind the wall, and you flip that switch and hopefully what you'd see is that water being discharged and not waiting for tide to proceed. Sort of getting a head start on the tide is really what the pump station would provide.
Because the pump stations have wireless, so that there's a float switch, so that when, if in the swamp area or marsh area, it hits a certain level, and you know a nor'easter's coming in, and we need the capacity in the marsh, then you drain the marsh before the storm hits. You have the capacity. It can all be done electronically.
Please.
I like that. Is it a generator that it has?
The pumps can either be modular, that you can move them around the city, or it can be a stationary pump house with a generator in it. And the pump house will be designed with clapboard. It would look like one of your neighbor's house. It will be small, maybe whatever size.
Would now be a good time, Paul, for you to introduce the hazard mitigation plan and what we're doing there? It's just, if people are not aware, every 5 years, the city's required to update its hazard mitigation plan as part of FEMA. If you don't have an updated plan every 5 years, you're not eligible for a whole bunch of FEMA money. So the city has been putting that together, and one of the things we have to map is the repetitive loss areas. Well, guess who's the #1 repetitive loss area in the city? It's this area, literally. You have the most number of triangles that are like dense right on top of each other in this area, because it's the known flooded area. So as part of the hazard mitigation plan, the city has to submit listing all sorts of projects that not that the city's committing to, but that wants to do if it had the money to do it, or had the funding from FEMA or MEMA or someone else to do it. Well, some of the ones that Paul and the team has identified clearly, Paul, you want to just, you already mentioned the stationary pump system, a mobile pump system.
Yeah, some of the upgrades to the tide gates. State and federal governments will have funds available. In order to qualify for that funding, you need a hazard mitigation plan, and you have to be an MVP, a municipal vulnerability plan. It gets submitted to FEMA, and they approve it, then you can start applying for these grants. Tide gates, pump stations, they all pump stations. Yeah, generators. The Strand, we lost our generator at the Strand, so we're moving that, increasing the elevation of that. So all those municipal assets that are vulnerable during a major storm are eligible for grants.
So the vulnerability that I'm curious about is, in the interim, you know, part of the issue was we lost power to the tide gate. What is the interim plan for making sure that there's backup for the tide gate until whatever gets constructed gets constructed?
I think they bought a generator, mobile generator. Yeah. The city has mobile generators, so if that happens again, we should bring a generator down. The problem with the area was that it flooded out.
Right, well that's,
So trying to get a generator in there.
right,
So
so,
the mobile pumps we talked about, the city has mobile pumps.
And last time,
Yeah, we can talk about doing something now, you know what I mean?
That's-
So it's up high and
If
it's
it's-
able, we're able to get at it.
because
be
if
able to
this
turn
is
it
like
on.
3 years out,
Yeah, no, that's totally understandable
you
to,
know, and my other question is, and I know we're not really touching on it, is the drop inlets that feed into the green marsh that are currently bricked up. I think you mentioned you're having a meeting with MWRA to discuss.
well, it's really,
That's sort of,
Army Corps of Engineers.
sorry, Army Corps.
Ourselves, MWRA and Tiger Bond and Al, Paul and actually PJ Foley, who's been involved in a lot of that, is gonna stick his head into, just to talk about how we can go forward sooner than later to address that and turn that into a usable, city-operated, hopefully, and I don't think anybody's gonna have any turf wars over who runs it. So we were able to use that as the back door to get water out, so
That was
that's,
my understanding, that was the original purpose of that drop inlet, was that was like the emergency,
yeah, that's been stoned up
Right.
since after World War II or something.
yeah.
And there's a,
I stuck my head in there, they're about ready to collapse.
yeah, and
Careful.
Yeah.
I didn't go that close, but I,
we
you know,
got a couple
enough to
of
see that-
spirited house neckers that, you know, can sometimes utilize themselves and to open it up to let it out or off and on, but we don't wanna go that route anymore. We wanna make sure that we're running it, it's in there efficient, and it's back to normal. And it's been probably something, PJ probably can add to that, because he dealt with the marsh restoration, but been going on for a while to get at. And MWRA, in just brief conversation, really didn't have any problem with us, you know, doing anything with it. The Army Corps, who I've talked to a couple times, like I said earlier on phone tag, get them in, just make sure we're all on the same sheet of music. Planning to have that in early November, a meeting with them, with everybody that I just mentioned, to get that started and have it so it's working right, you know.
There's a design element that would be involved, and some permitting, I believe, right, David?
There's some intense
yeah.
permitting,
Yeah, so.
Yeah.
very difficult permitting.
It has to be addressed though. It's too low, never get it out. I mean, we talk about pumping. I mean, that's an area that would have to be addressed, but we should address that, and that would be a great way to let all that water out that settles down. It's probably the lowest point by that boardwalk, besides the marsh behind Post Island, the two, valleys.
Is there any discussion about doing invasive species mitigation? Because that Phragmites does an excellent job mucking up the works.
I have not gone down that avenue yet.
Actually,
Sure that'll
to that
come.
point,
Actually, as part of the hazardous mitigation plan, there is, one of the sections in there is to deal with invasive species.
Okay.
it's an excellent point, and one of the things is if you get the salt water flowing in the way it's supposed to, that'll take care of 90%.
It'll help a lot.
Yeah.
In both of the marshes.
Yeah. No,
If
it's,
you want to pull Phragmites, let me know.
I think the
Just
whole
when you get a
thought,
permit.
The Army Corps and
Yeah.
EPA, their desire is to have full tidal flush of the ebb and flow of the normal tide to go in and out of there. Obviously, when that happens, some of those lower lying properties get flooded, especially during the monthly, highest high tide during the monthly tide. So there's that balance, and EPA doesn't want that restriction. EPA wants the full flow back and forth. They do not want the tide restricted.
They don't like tide gates.
Right.
And then they don't want the bottom floor of it to be hard. They want it so species can properly flow back and forth.
If I can add one other thing, just
Please.
while we're looking at this photograph. On the back side of the dike, you can see where it's a light green, that's Spartina, that's a healthy salt marsh. On our side, that's all frag, dark green. And so there's good and bad right in front of you.
yeah. And I think this go around with the Army Corps and the folks I just mentioned, we have to come up with a solution. We can't just spin our wheels and all go away, so, priority.
This could be too, one of the key and, potentially quickest things to deal with drainage, because, again, the wall could take quite a while, for this 1,000 blocks, 1.5 million section with a lot, all the variance that goes into that. But this might literally, save us from having C Street flooded repeatedly and,
Definitely.
Yeah.
I think,
Final thing I just want to mention is, as we go through with the wall, there will be disruption along everybody's property. We'll try to minimize that disruption to the property, but there will be sections where there's patios and there's some of those are just absolutely drop dead gorgeous. So right now, the plan is, as discussed by the city, is to replace in kind. So the contractor will be required to, whatever is disrupted will be replaced and restored to what's there today. So, but
we got a Reader's Digest look as we walked along on who's, right up that we're saying, okay, we gotta, this has gotta go back further. There were places where this is fine, so we'll go through it house by house, so people will know.
Can you put up on the GIS with the property lines on?
Yeah.
Just, there are several places where, whereas we raised the wall, the city has agreed to and wants to increase the number of public access stairs. So publicly constructed stairs. There are several spots where there are easements through there, but no public stairs. So where there is an easement and an access way, we will be adding a public stair there.
So this is 738 C Street. There's a right-of-way here in between that address and 744. We're proposing a stair on that side. There is a public stair, and these are on that board on that side. You'll see what we have is existing public access points are in green. In blue, we have proposed public stairs, so there's 2 additional public stairs that would be added as part of this. And then I believe the other one is right, that's it right here. So we got one there, and then there would be another one on this side right here.
I think that's a much better attack right now. I know there'll be other questions, I know probably have other meetings. Like I said, October 9th is Post Island and include, we're actually gonna let Tom Kelly come again, South Road. Didn't ask any too many tough questions. But, you know, all the way up, that's October 9th. Then we have one a little bit later on for the Norton Road, Chickatawbit Run. That doesn't mean we won't circle the wagons again if we all of a sudden come to grips with something that is a knuckleball and we have to, you know, come back. But you know, I gotta tip my hat. First of all, the involvement of the neighbors has been great. Because I know in conversations with Paul especially, Mike Carter's comments, Charlie Cote, the whole Post Island, the C Street folks that were there at the other meeting. You know, and I know it gets a little higher when we get up to Chickatawbit. I'm sure they'll be there in force, but we knew we were gonna get some solid information off an experienced group on C Street and Post Island Road, and tip my hat to these guys, you know, all the way since January, March and whatever, you know, have helped me answer the mail, pretty damn good. So, I think we'll get there and we'll just keep working and, take all suggestions and make it all work in the end. And, you know, yesterday I had a conversation with the mayor, about this, and Chris Walker, really brief, just about what we kind of came back with after we had our meeting a couple of weeks ago, about the style and the railings going away, the width, the height, and, you know, he's all in. He thought it was, the meeting that we had was great. He thought that the breakup of the meetings we're conducting now will be able to encapsulate the different areas so we can move forward with folks' needs, either 2 feet, 4 feet, pump houses in strategic areas, and I'll leave that to the pros, but it's good to have their backing behind you when you get involved in this, so all good. With that, we'll wrap it up. Plenty of cookies here if you want to take them home.
If anybody wants notes and I don't have your email address, let me know and I'll put you on my list.